In 7.2, we're going to focus on transformation called a reflection. So there are different properties of a reflection, and the first um, is when you do a reflection, um, the distance from the pre-image to the image, um, from the pre-image to the line of reflection is going to equal from the line of reflection to the image. So this length is going to be the same as this length, and this is also a right angle. A reflection is an isometry. Remember, an isometry length is preserved. So if you had a square with side lengths of 3, when you do the reflection, it's still going to have a side length of 3. So we're going to reflect the point 3, 5 in the y-axis. So we plot the point first over 3, 5. Call this point A. That's the pre-image. And if we reflect it over the y-axis, if it's 3 units away from the y-axis, we got to go 3 units away on the other side. And that's going to be A prime. Okay, notice this is a right angle there. If we want to do point B from -2, 4, so that's point B, and we're going to reflect it in the x-axis. It was 4 units up. Now we have to go 4 units down. 3, 4. This is going to be B prime. So at right angles and the same distance from the line of reflection. Now we're going to do the same kind of thing. Reflect the image over line K. On your homework, you're going to probably have a question like this. Make sure you trace it. Put your piece of paper over the book. Trace the line and this image. Don't just draw this part, because that doesn't. You need this and your resulting image. And also take your time. I'm going to kind of sketch out a little dotted line and make it a right angle from over the line of reflection. I'll do the same thing with some other points, and this is where it gets a little tricky. If you had a ruler, it might be easier, but I'm going to continue to reflect this over. And about, I'm guessing here, trying to make sure this length and this length are the same. And I think, I don't know, it looks maybe a little bit off, but once I kind of get one side in, I can kind of piece the other sides in. I know this is kind of a right angle. I'm just going to go over at a right angle, about that length and up. Looks like it's a little bit longer, and then connect these things together. So kind of piece it in. If you do something like that, show a couple of these lines between your pre-image and image, and keep this at a right angle, and this length and that length about the same. I'm going to be pretty happy. Um, it's not going to be perfect, but that's pretty good reflection. What I don't like seeing is if you had, let's reflect this smiley face over this line, and you just kind of do this. Now that's not a very good reflection. You might be able to see that this eye would need to, you need to, definitely doesn't line up. And if you reflect it over this line when it's angled, it's going to be twisted a little bit more. The mouth would look more like this. So take your time so that it makes sense. It works. One thing you can do is use reflections when you're playing pool and doing geometry when you're playing a game like billiards. Just real quickly, if I want to shoot the blue ball into this hole, or maybe Yeah, let's do the blue ball. I would want the blue ball to go that path, so then I'd want to hit the white ball so that it would hit at that spot. I'd shoot it here, and this ball would reflect into there. Now it gets a little bit harder if I want to shoot the blue ball, say, into this pocket. And what you can do is you can actually use a reflection and slide this thing up on the... It didn't work there for a second, but put it right up here, and we can use this reflection. So this pocket is being reflected down into here. So what I'm going to do is I'm going to line the blue ball up like this. So if I want the blue ball to go into that pocket, I'm going to need to hit the ball right here, and then the ball is going to reflect off the rail and go into this pocket there. So I'd need to hit the white ball right there to make the shot happen. White ball hits there, it's going to hit the blue ball, hit there, and that's going to reflect in. So you can, this is how good pool players can visualize where to hit the ball. Oftentimes you see them step around to the side of the table, and they visualize that angle. And you could do multi-rail shots, have it bounce off 3 rails and then go into a hole by doing multiple reflections. A couple other things in this section: lines of symmetry let me get my line maker out, but a line of symmetry is sometimes people call them folds, where I can fold this shape and a corner would map onto itself. So here would be one line of symmetry in the square. There would be another line of symmetry where I could fold this side over to that side. Since this is a square, I could fold right along this diagonal or this other diagonal. So the lines of symmetry then, how many lines of symmetry does this square have? This would be my first one, second one, third one, fourth one, and notice we already counted this one up there. So a square would have 4 lines of symmetry. Now you got to be careful here. Is this a line of symmetry? You got to be careful. I'm going to say it's probably not going to be, because if I fold this, okay, I'm trying to make it a right angle there. If this is a right angle, notice this point is not going to map up to that point. So that first blue line is not a line of symmetry, so we want to get rid of that. The question is there any other lines of symmetry? If we went this way, this way, this way, is that a line of symmetry? A lot of people might say, hey, yeah, that's a good one, but once again, if I reflect this point over, I have to reflect it over at a right angle. So this point would have to go over there. That's not a line of symmetry. So I'm going to say there are no lines of symmetry on that problem there. This one, back to more of a regular shape. 1, 2, 3, 4, and the last one's kind of off a little bit, but you can see there's 5 lines of symmetry. Is that a line of symmetry? Sure is. This point will match up to that one. 1 line of symmetry. A star is going to be a lot like this one. I think there's going to be 5. I can go from each corner to the indent. And 1, 2, 3, 4, 5, and I already counted that one. and here we have 1. The kaleidoscope is one way we can see lines of symmetry, and you might notice a line of symmetry right there. It's off a little bit, and here's another one. There's one. Is there any other lines of symmetry? Well, actually there's ones through each of these green ones. So there's quite a few lines of symmetry in a kaleidoscope. Usually a kaleidoscope is made of just mirrors. And here I had it already made out, but those are the lines of symmetry in that more complex shape. There's your homework. If you got questions, make sure you bring them and ask them. Have a good night.